Okay, so we're going to start section 2.2, trigonometric ratios of any angle. We are going to find our trig ratios of any angle between 0 and 360, including 0 and not including 360. Consider that theta is any angle in standard position, and P, with coordinates of x and y, is any point on its terminal arm at a distance r from the origin. Then, by the Pythagorean theorem, r is equal to the square root of x squared plus y squared. You can use a reference triangle to determine the three primary trigonometric ratios in terms of x, y, and r. Okay, so keeping in mind that sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. Alright, so let's take a look at our reference triangle, which is over here on the right. Our point is x, y, and note that in the first quadrant, x is positive, y is positive, and so along one side of our triangle we have a distance of x, and along one side we have a distance of y, both being positive. And theta is our angle in standard position, and r is our radius, which goes from the origin out to our point. Alright, so just to take a look at why r is equal to the square root of x squared plus y squared. Using Pythagoras' theorem, we know that r squared is equal to x squared plus y squared. And if I want to solve for r squared, that means I want to take the square root of both sides, and so I get r is equal to the square root of x squared plus y squared. Okay, now r is always considered positive, which is why we don't put plus and minus in front of our root bracket. Okay, alright, so let's take a look at why sine of theta is y over r. If you look at your diagram, here's our angle, and opposite to our angle is y. And so because sine is opposite over hypotenuse, we go y over r, and so in the first quadrant sine of theta is y over r. And cos of theta is x over r because the side adjacent to theta is x, and so by definition cos of theta is adjacent over hypotenuse, so therefore x over r. And tan of theta is by definition opposite over adjacent, so opposite being y, adjacent being x, therefore y over x. Now the chart below summarizes the signs of the trig ratios in each quadrant. In each, the horizontal and vertical lengths are considered as directed distances. That means that they are positive or negative, okay, depending on which quadrant the point P is in. Okay, so let's take a look at our diagram. We'll start in the first quadrant. We already know from above that sine theta is y over r, cos theta x over r, tan of theta is y over x. Both the coordinates x and y are positive in the first quadrant, so that means that each of your trig ratios must be positive. And so we say sine of theta is greater than 0, cos of theta is greater than 0, tan of theta is greater than 0. And remember, when we say greater than 0, we mean positive. Okay? Alright, so let's take a look at what happens in the second quadrant. Now your point is negative x and y, because in the second quadrant, x is negative and y is positive. And so when we go to work out our trig ratios, we need to keep in mind that the x is negative and the y is positive. Alright, so our angle now is in the second quadrant, which means that this is our reference angle, okay, theta subscript r, and opposite to that is y, and adjacent to that is x. So sine of theta is opposite over hypotenuse, so y over r. Cos of theta is adjacent over the hypotenuse. So in this case, notice your x is negative, so negative x over r. And tangent of theta is opposite over adjacent, so y over negative x. So take a look. Your sine theta is positive, so greater than 0. Your cos of theta is negative, right? Because you've got negative x over r. So now cos of theta in the second quadrant is negative. And tangent of theta is also negative because you're dividing y by a negative x, and so tan of theta is negative. So the only trig ratio in the second quadrant that's positive is sine. The other two are negative. All right, let's see what happens in the third quadrant. Now, any point in the third quadrant has a negative x value and a negative y value. Okay, so we're now taking a look at this angle here, the red arrow, and so our reference angle is right here. Opposite to that is negative y, and adjacent to that is negative x. So now our sine of theta is opposite negative y over the radius, which is r, the hypotenuse, which is r, and so negative y over r. So take a look, sine of theta is negative, so less than 0. Cos of theta is adjacent over hypotenuse, so in this case negative x over r, and take a look, because x is negative, our cosine is still negative in the third quadrant. But look at our tan. It's opposite over adjacent, so negative y over x, and remember, a negative divided by a negative is a positive, and so tangent is now positive in the third quadrant, and the only trig ratio that's positive in the third quadrant, the other two being negative. Okay, let's take a look in the fourth quadrant. We have a point now where x is positive and y is negative, which is true for any point in the fourth quadrant. And our angle now goes almost a full circle. Our reference angle is right here, and so our opposite is negative y, and our adjacent is positive x. Okay, so what does that do to the signs on our trig ratios? Okay, well, sine of theta is negative y over r, okay, because opposite over hypotenuse, and so our sine is negative. Cos of theta is x over r. Okay, and note, x is positive this time, so x over the hypotenuse, so x over r, greater than 0. And tan of theta is negative y over x, so opposite over adjacent, and therefore negative, because we only have one coordinate, which is negative, and so tan of theta is less than 0. Okay, so to summarize, in the first quadrant, all of your trig ratios are positive. In the second quadrant, the only one that's positive is sine, the other two are negative. In the third quadrant, the only trig ratio that is positive is tangent, the other two are negative. And in the fourth quadrant, the only trig ratio that is positive is cosine, the other two are negative. Okay, now that is really important information to remember, so we have a little memory device over here on the right. It's called the cast rule. So the way you work the cast rule, you start in the fourth quadrant and you go counterclockwise to spell cast. Okay, so here's our coordinate system. We have quadrants 1, 2, 3, and 4. So in the fourth quadrant, we start with C for the first letter of cast, and then in the first quadrant we have A for the second letter in cast. In the second quadrant we have S for the third letter in cast, and in the third quadrant we have T for the fourth letter in cast. So if you start in the fourth quadrant, go counterclockwise, spell cast. C means that cosine is the only trig ratio that's positive in the fourth quadrant. A means that stands for all, which means that all of your trig ratios are positive in the first quadrant. S stands for sine, which means that sine is the only positive trig ratio in the second quadrant. And T stands for tan, which means tangent is the only trig ratio that is positive in the third quadrant. Okay, so that ends our discussion for our introduction. Okay, example 1. Write trigonometric ratios for angles in any quadrant. The point P, negative 815, lies on the terminal arm of an angle theta in standard position. Determine the exact trigonometric ratios for sine theta, cos theta, and tan of theta. Okay, so let's start one by drawing a diagram. Okay, of our angle in standard position. So we know that we have a point where x is negative 8 and y is 15, so we'll estimate that it is around here. Okay, so P, negative 8 and 15. We want to draw our angle in standard position, so we will draw in our initial arm, and then we will draw in our terminal arm and make sure it goes through your point P. give your angle direction. And keep in mind that between the terminal arm and the x-axis, we have our reference angle theta subscript r. Okay, so we want to draw in our reference triangle. We're going to drop a line from our point perpendicular to the x-axis. Along the x-axis, the direction we have is -8, and along the y direction we have a +15. Okay, and before we start determining what our trig ratios are, let's just recall our cast rule. Okay, start in the fourth quadrant and spell out cast going counterclockwise. And just note that when we do finally determine what our trig ratios are, that because we're looking at an angle in the second quadrant, sine is the only trig ratio that will be positive. Okay, the other two will be negative. So when you work out your trig ratios for the angle in standard position that has a point -815 on the terminal arm, be sure that sine is positive, cos is negative, and tan is negative. Okay, so our second step. We want to recall our formulas that we derived in our introduction. That sine of theta is y over r, cos of theta is x over r, and tan of theta is y over r. Now, because we already have a point -8 and 15, we know that x is equal to -8 and y is equal to 15. We don't know the value of r, so that's going to be our next step. We want to find r. So we'll use our Pythagorean theorem, where we know r is equal to x squared plus y squared. Substitute your values in for x and y and determine the value of r. And you get that r is equal to the square root of 289, which is 17. Okay, so our third step then is to determine the exact trig ratios. Okay, so sine of theta is y over r. So sine of theta is 15 over 17. Cos of theta is x over r. And so cos of theta is equal to -8 over r, which is 17. And tan of theta is y over x. So tan of theta is 15 over -8. Or if you like, tan of theta is equal to -15 over 8. Okay, so using our little formulas here and determining what our sine, cos, and tan ratios are, is sine positive, cos negative, and tan negative? And it is, right? If you take a look at sine of theta, it's 15 over 17, that's positive. Cos of theta is -8 over 17, that's negative. And tan of theta is -15 over 8, which is also negative. Okay, and that concludes example number 1. Okay, so example 2, determine the exact value of a trigonometric ratio. And we are asked to determine the exact value of cos 135 degrees. Okay, so in this example, you're asked to find an exact value. That should get you to recall your special angles, which are 30 degrees, 45 degrees, and 60 degrees, because most likely that's what you're going to be using in this question. Okay, so the first thing that we want to do, we want to draw a diagram. 135 degrees in standard position. Okay, and we know that 135 degrees is in the second quadrant because it's between 0 and 180. So let's draw our initial arm and then our terminal arm and our angle in standard position, which is 135 degrees. And our next step is to determine our reference angle. Okay, now you know that your reference angle is between the terminal arm and the x-axis. Okay, so a full half circle is 180 degrees. Up to our terminal arm is 135. So if we want to work out our reference angle, we want to go 180 minus 135, which will give us an angle of 45 degrees. Okay, so our reference angle is 45 degrees. Okay, so yeah, when we said that we're probably going to be looking at our special angles, one of them is 45 degrees, so we will be using that. Okay, so our third step is to draw a reference angle. Or sorry, reference triangle. Okay, so we want to drop a line from our terminal arm perpendicular to the x-axis. Okay, and as you can see, we have a 45, 45, 90 triangle, which means that the ratios of our sides are 1 to 1 to root 2. Okay, and remember that the root 2 being the largest side is our hypotenuse, so that would go along here. And the 1 will have a 1 here and a 1 here. Now remember that our x and y have directions, so the direction on our x is a negative, and the direction on our y is a positive. Okay, and now we can write our ratio. Okay, we know that cos of theta is equal to adjacent over hypotenuse, and so cos of 135 degrees is equal to our adjacent side, and adjacent to our reference angle is -1, and our hypotenuse is root 2. Okay, and take a look. Your cos of 135 is a negative trig ratio, which you would expect because if you recall cast, in the second quadrant, it's only sine that's positive, and so you would expect your cosine to be a negative value. Okay, and that's the end of example number 2. Okay, example 3, determine trigonometric ratios. Suppose theta is an angle in standard position with terminal arm in quadrant 3 and cos theta is equal to -3/4. What are the exact values of sine theta and tan theta? Now, exact values in this question doesn't mean that you need to refer to your special triangles. What it means is if you do get one value in your work that's a square root, you don't work it out as a decimal, you leave it as a radical. Okay, so our first step is to draw theta in standard position. Okay, we know it's a third quadrant angle, Okay, so here is our initial arm, and here is our terminal arm in the third quadrant. Give our angle direction. Okay, and recall that your reference angle is between the x-axis and the terminal arm. Okay, now we do know that cos of theta is -3/4, so we are going to get some information from there. So in our second step, we want to determine what that is. Okay, so we know that our formula to determine cos of theta is x/r. So if cos of theta is equal to -3/4, then we do know what x is and we do know what r is. Okay? Now remember that r is always going to be positive. Okay, so this negative sign on your cos theta then is going to belong to the 3, not the 4. Okay? So we know that x is equal to -3 then, and that r is equal to 4. Okay, now because we do want to find sine theta and tan theta, and we know that their ratios are y/r and y/x respectively, then we need to find out what y is. So our third step is to determine y. And what we want to do is keep in mind that y is in the third quadrant, okay, which means that it has to have a negative sign. Okay, so let's pull out our Pythagorean theorem again using x, y, and r. So we would have that x squared plus y squared equals r squared. We can substitute in -3 for x and 4 for r, so that gives us 9 plus y squared equals 16. And so y squared is equal to 7, and y then is equal to plus or minus the square root of 7. But we are going to choose -√7 because we know that y is negative in the third quadrant. Okay, so therefore y equals -√7. Okay, next we are going to draw our reference triangle. Okay, so bring a line perpendicular from your terminal arm up to the x-axis. We know that x is -3, and we know that y is -√7, and we know that r is 4. Okay, so why don't we just write that down here. We know that x is -3, y is -√7, and r equals 4. Okay, and so the next thing that we can do then is to determine sine theta and tan theta. Okay, so we know that sine of theta is y/r. Okay, so sine of theta then becomes -7/4. And we know that tan of theta is y/x. And so tan of theta is going to be equal to -√7/3. And so we know that tan of theta is equal to the positive square root of 7 over positive 3, because a negative divided by negative is a positive. Okay, so just to revisit what we mean by exact values on this in this question, if you take a look at your sine and tangent, we have negative root 7, okay, or positive root 7 for tan of theta. But what exact value means is that we don't want to work those out as decimals. We need to leave it as a radical. That's what makes it exact. Okay, and that ends our discussion for example 3. Okay, example number 4. Determine trigonometric ratios of quadrantal angles. Alright, so we're going to need to know what those are. So we're on the right. Quadrantal angle is an angle in standard position whose terminal arm lies on one of the axes. Examples are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. So if you recall from earlier diagrams, here is 0, 90, 180, 270, and 360. And there's actually more of them, because if I keep rotating around the circle, I can just go 360 plus 90 and get another one over here, and then add another 90 and get another one here, and add another 90, get one here, another 90 and get one here, and so forth. Just keep going around the circle. Okay, so there's an infinite number of them. Okay, so we are going to determine the values of sine theta, cos theta, and tan theta, where the terminal arm of quadrantal angle theta coincides with the positive y-axis, and that's where theta equals 90 degrees. Now we have to approach this differently than our last couple of examples, because we won't be able to draw ourselves a reference triangle. Okay, so the first thing we're going to do is we're going to let the point P, X, Y be any point on the positive y-axis. Okay, so what that means then is that X is going to equal 0, because any point on the y-axis has a coordinate of x, which is 0. And we will also find that r is equal to y. Okay, so let's draw ourselves a picture to see why that is true. Okay, so in standard position, 90 degrees looks like this. Okay, and our point P, because it's on the y-axis, has an x-coordinate, which is 0, and a y-coordinate, which we will just leave as y. Now, we can't draw ourselves a reference angle for the reference triangle for this. What we can do, though, is we can consider a point moving around a circle. Okay, and so it would look something like this. Okay, so this point here will move counterclockwise around a circle. Okay, and so we can see that from the origin to our point is r, and that would be true over here too. Okay, and because we're considering our point being on the y-axis, we can also see that not only is the distance from the origin to our point r, the distance from the origin to our point is also y. Okay, and so we can see that r is equal to y. Alright, so the third thing that we want to do then is to determine what our trig ratios are. Okay, we know that x is equal to 0, y is just y, and we know that r is equal to y. So let's take a look. We want sine of 90 degrees, and our little formulas from earlier tell us that sine of 90 degrees will be y over r. And so sine of 90 degrees is equal to, well, we're going to keep y as is, but our radius is now y. And so we can see that sine of 90 degrees is y over y, and y over y is equal to 1. Okay, so now cos of 90 degrees. We know that that is x over r. And we know that x on the y-axis is 0, so 0 over, we know that r is y, so we'll put 0 over y. And the cos of 90 degrees then is 0 over y, which is 0. Okay, tan of 90 degrees is y over x. Okay, so tan of 90 degrees, well, y stays as y, but x is equal to 0, so tan of 90 degrees then is y over 0, which you know is undefined. Okay, so these are your trig ratios for 90 degrees. Sine of 90 is 1, cos of 90 is 0, tan of 90 is undefined. So that will end example 4. Okay, so we're going to do a your turn. If you would like, you might want to try working this out on your own and then come back and view the video. So you're asked to use the diagram to determine the values of sine theta, cos theta, and tan theta for quadrantal angles of 0 degrees, 180 degrees, 270 degrees, and then organize your answers in a table as shown below. Okay, so let's start with 0 degrees. When we have a quadrantal angle at 0 degrees, our point xy now becomes x and 0. And that's because any point on the x-axis has a y-coordinate of 0. And because we're on the positive x-axis, our value for x will be positive. So for our quadrantal angle of 0 degrees, we know that x is just going to be coordinate x, and we can see that y-coordinate will be 0. Alright, so keeping in mind that we can consider a circle that goes through our points. Okay, and we want to do that because we can't draw reference angles. Then we can see that the radius of this circle goes from the origin out to our point x0. And we also know, though, that the distance from our origin to our point is also x, so we can see that r is equal to x at 0 degrees. Okay, so we want to write our trig ratios. So sine of 0 degrees is y over r. The value for y is 0, and our radius is x, and so 0 over x is 0. Cos of 0 degrees is x over r. The value of x is still x. The value of r, though, is now x, and x over x is 1. The tangent of 0 degrees is y over x. Y is 0, x is x, and 0 over x is 0. Okay, so our sine of 0 degrees is 0. Our cos of 0 degrees is 1, and our tan of 0 degrees is 0. Okay, so let's move over to 180 degrees. Now, as you can see, x has a direction of a negative direction. Okay, so we now have a negative x. Y, once again, on the x-axis is 0. And once again, our radius goes from the origin out to our point, but so does our value for x go from the origin to our point, and so r is equal to x. And remember, the radius is always positive, so we need to consider x as being positive when we equate r to x. Okay, so at 180 degrees then, x is negative x, y is 0, and r is equal to x. So sine then of 180 degrees, being y over r, is 0 over x, which is 0. Cos of 180 degrees is x over r. Okay, well, x is negative x this time. R is x, and negative x over x is negative 1. And tangent of 180 degrees is y over x. Well, y is 0, x is negative x, but 0 divided by anything is 0. So we can put this on our table now. At 180 degrees, sine of 180 is 0, cos of 180 is negative 1, and tan of 180 is 0. Okay, so the last one on our table is 270 degrees, so let's take a look at that. Okay, at 270 we are back onto the y-axis, so our point on the y-axis has an x-coordinate of 0, which it would anywhere on the y-axis. Our y now is negative, right, because our direction is negative, so y is negative. And r, once again, from the center of the circle to the point, is going to be the same as y. And just recall again, r is positive, so y will be positive. So at 270 degrees, we know that x is equal to 0, y is equal to negative y, and r is equal to y. So sine of 270 degrees is y over r, so negative y over y, which is negative 1. Cos of 270 degrees is x over r, and x is 0, r is y, and so 0 over y is 0. And tangent of 270 degrees is y over x, y is negative y, x is 0, and anything divided by 0 is undefined. Okay, so let's fill our chart in. At 270 degrees, sine of 270 is negative 1, cos of 270 is 0, and tangent of 270 is undefined. Now, what if we were to add another column onto here and make it 360? Okay, now we know that 360 is a full circle, so it shares the same terminal arm as 0 degrees. So what that means then is that your trig ratios for 0 degrees are going to be the same ones that you would have for 360. So 360 degrees shares the same trig ratios as 0 degrees, so we can fill the chart in as 0, 1, and 0. Okay, so this concludes our discussion on quadrantal angles. Okay, so our next two examples will be taking a look at solving trigonometric equations. That means we're going to be solving for an unknown angle when we are given their sine, cosine, or tangent. So there's three steps that we want to take a look at. the first step is to determine which quadrants the solution or solutions will be in by looking at the sign positive or negative of the given ratio. That means that you will want to remember your CAST diagram, your CAST rule. Step 2 is to solve for the reference angle. Step 3 is to sketch the reference angle in the appropriate quadrant and then use the diagram to determine the measure of the related angle in standard position. Okay, so our first example, number 5, is to solve for an angle given its exact sine, cosine, or tangent value. So exact, meaning that you need to remember your special angles, right? 30 degrees, 45, and 60. So we're going to be asked to solve for theta. Our first one is sine theta equals 0.5, and we're looking for an angle which is between 0 and 360. So the first thing that you want to do is to determine which quadrant or quadrants your angle will be in. And because our sine of theta is 0.5 and the 0.5 is positive, that means that our sine ratio is positive. And if it's positive, we need to determine where between 0 and 360 sine can be positive, and that's where our CAST diagram comes in. Okay, so where is sine positive? Well, all trig ratios are positive in the first quadrant, so sine will, one of our angles will be in the first quadrant, and in the second quadrant sine is positive. So that means we are going to have another angle which is in the second quadrant. So we are going to have two solutions where sine of theta is equal to 0.5 degrees. Alright, our second step is to solve for the reference angle. So sine of theta subscript r. Our reference angles are all going to have positive trig ratios, okay? So we can leave our 0.5 as 0.5. And the reason for that is your reference angles, if you recall, are between 0 and 90 degrees. And where sine is positive for sure, we know is in the first quadrant, okay? And so we can leave it at 0.5. Okay, now the other thing, because we're looking for exact values, sine of theta being 0.5 is also 1 over 2, and if you recall, you would need your 30, 60, 90 triangle to determine what the value of theta is when the sine ratio is 0.5. Alright, so here is your 60, 30, 90 triangle. Remember, opposite the 30 degrees, the side is 1. Opposite the 60 is root 3. And opposite the 90 degrees is 2. Now, we know that sine of theta is opposite over hypotenuse, which means that our side 1 is going to be our opposite side. Okay, and then of course our hypotenuse is 2. But if 1 has to be the opposite side, what angle is it opposite to? And it's opposite the 30-degree angle. So that means that our reference angle, theta, is 30 degrees. Okay, so step 3 is to sketch the reference angle in the appropriate quadrant or quadrants. Well, quadrants in this case, right? Because we're going to have two answers. So let's draw that. Okay, so whatever our first angle is, it's in the first quadrant. And we also have a second angle which is in the second quadrant. So theta can either be here or here. Alright, we do know that we have a reference angle of 30 degrees, so in the first quadrant it is here, and so theta subscript r equals 30. And in the second quadrant, it's right here, right, between the terminal arm and the x-axis. So we get our reference angle of 30 degrees in the second quadrant. Okay, well, as you can see from the diagram, our reference angle and our first angle in the first quadrant is the same. Okay, so our first quadrant angle is 30 degrees. Our second quadrant angle well, we would calculate it because we know that half a circle is 180 degrees. We know that up to our terminal arm is unknown, but between the terminal arm and our x-axis is 30 degrees. So I can find theta by minusing 30 from 180, and I find that my second quadrant angle then is 150 degrees. So the last thing that I want to do then is I want to state my solution. So the solution for sine of theta equals 0.5, where theta is between 0 and 360 degrees, is that theta could be 30 degrees or 150 degrees. Okay, so that one is now solved. So now let's take a look at our next example, B. We are asked to solve cos of theta equals negative root 3 over 2. And take a look at your restrictions now. Your angle theta can only be between 0 and 180 degrees, which means that there's only a possibility that it could either be in the first quadrant or the second quadrant. Okay, no other quadrants. So let's determine which of the two it is. We know that cos of theta is negative root 3 over 2, and because negative root 3 over 2 is negative, we know that our cosine ratio is negative. And so where are we going to find that cosine is negative? So we take out our cast diagram. And like I said, it can only be the first or the second quadrant. So we need to determine where cosine is negative. Well, in the first quadrant, all our trig ratios are positive, so it can't be a first quadrant angle. But in the second quadrant, it's only sine that's positive. Cosine is negative here in the second quadrant. So therefore, theta is in the second quadrant. Okay, so now we want to determine our reference angle. In order to do that, I need to make my negative root 3 over 2 positive because my reference angle needs to be between 0 and 90 degrees. So I'm looking for something that could be a first quadrant angle, right? So I need to make that positive. Now, root 3 over 2 should suggest to you once again that this is a 30, 60, 90 triangle. So let's take a look. Here we have 60, 30, 90. Okay, so here's our 30, 60, 90 triangle. Side opposite the 30 is 1, side opposite the 60 is root 3, and side opposite the hypotenuse is 2. I know that cos of theta is adjacent over hypotenuse, and my root 3 needs to be the adjacent side. And so root 3 is adjacent to which angle? Well, root 3 is adjacent to the 30-degree angle. And so I can see that my reference angle then, my reference angle is 30 degrees. Okay, so now I want to draw my angle in standard position. And with a reference angle of 30 degrees. All right, so I know it's in the second quadrant. And I know that my reference angle is between the terminal arm and the x-axis. And so if I want to figure out what theta is in the second quadrant, I would go 180 minus 30 to get 150 degrees. Okay, and I know that I need to minus 30 from 180 because half a circle is 180. And when I subtract the 30 degrees, that will bring me up to this reference angle and tell me that the angle, which is indicated by the red arrow, is 150 degrees. And so then I state my solution. The solution to cos of theta equals negative root 3 over 2, where theta is between 0 and 180 degrees, is 150 degrees. Okay, so that ends this discussion for example number 5. Okay, so example number 6, solve for an angle given its approximate sine, cosine, or tangent value. Okay, so we are looking for something that's approximate, which means that we're not using our special angles. That will mean that you will be using your calculator, so you'll need to pull that out. And just a reminder to be sure that your calculator is in degree mode. Okay, so let's get started. Given that cos of theta equals negative 0.6753, where theta is between 0 and 360 degrees, determine the measure of theta to the nearest tenth of a degree. Okay, so our first step is to determine which quadrant our angle is in, or which quadrants. Now we know that cos of theta is negative 0.6753, and negative 0.6753 is negative, of course, which means that your cosine ratio is negative. So let's find out where cos is negative. All right, so let's draw our cast diagram. All right, well, we know that all our trig ratios are positive in the first quadrant, and we can see that cosine is positive in the fourth quadrant. So cos will be positive in the first and the fourth quadrant. Only sine is positive in the third quadrant, so we're going to have a negative cos in the second quadrant. And only tangent is positive in the third quadrant, so cosine will be negative in the third quadrant. So therefore, cosine is negative in the second and third quadrant, and so theta is a second or third quadrant angle. Okay, the next thing we want to do is determine our reference angle. And remember, our reference angle needs to be between 0 and 90 degrees, so we are going to rewrite cos of theta as positive 0.6753 because I want to find a first quadrant angle, because that's going to give me my reference angle. So cos theta subscript r will be 0.6753. So theta subscript r is going to be cos negative 1 of 0.6753. Okay, so recall that when you're looking for an angle measurement, you want the inverse of cosine. Okay, so we're going to put that into our calculator. We're going to go second cos to get our cos negative 1, and we're going to put in 0.6753. and hit enter. And I can see that my calculator is not in degree mode, so let's do that. I want to go second mode and put my calculator in degree mode. Alright, let's try that again. Alright, second cos 0.6753. Enter. Okay, there we go. That's better because this looks like an angle measurement, whereas this one looked kind of too small. Okay, so that means that our reference angle to the nearest tenth of a degree is 47.5 degrees. And this is approximate, okay? Because we had to round that off, right? So it's not exact. Okay, so now we want to draw our reference angles in the second and the third quadrant, because that's where our angles can be. Okay, so here is our second quadrant angle. And here is our third quadrant angle. Okay, and both of them are theta. Okay, so let's draw our reference angles in. They are between the terminal arm and the x-axis. Okay, so we'll have one right up just above the x-axis and one below, but both of these are our reference angles, which are at 47.5. Okay, so let's determine our second quadrant angle. All right, so that means our first red arrow here. Okay, we know up to here is 100, so if I minus 47.5 from 180, that should give me theta. And that gives me an angle measurement of 132.5. And then in the third quadrant, instead of minusing 47.5, I'm going to add this time because I need to go past 180 for my angle in standard position. So I need to add, right, because the first part of my angle is 180 degrees, and then I have to add the 47.5. So this one is 180 plus 47.5 degrees, which is 227.5 degrees. Okay, and then we want to write our answer. So the solution for cos theta equals negative 0.6753, where theta is between 0 and 360 degrees, is that theta can equal 132.5 degrees, or theta can equal 227.5 degrees. Okay, and that ends our discussion for section 2.2.